Hello everyone, my name is Pratik Water, the co-founder and CEO of Applatix. I have with me Ed Lee, my other co-founder and CTO.
Hi everyone.
And Mukalika Kapas here, who's our Director of Product Management.
Hi everyone.
Thank you for joining us on this webcast, which is actually a continuation of a series of webcasts that we have had over the past couple of months. This one is focused around running AWS, Kubernetes, and containerized applications and services. The past webinars, we've talked about a number of topics, from why the public cloud is so much different than operating your private cloud environment. What are the best practices to set up when you're setting up your public cloud environment? How do you, once you have everything up and running, how do you manage costs? What are the visibilities and the tools that you can use? And we introduced one of our tools, which is Claudia, a free tool that we have made available that you can use. And then finally, we also been talking about why DevOps and containers need to be a central tenet in your journey to the cloud, right, in making that available. So today, I want to take a step to the side, because today we're going to be talking about, we're going to be a little selfish, and we're going to be talking about what Applatix is doing, right? And how easy it is to start, developing, deploying, and running containerized applications and services in the public cloud, right? So let's start with, how did we end up here, right? And the first thing, it would be to just, look at a quote. And this quote kind of sums it up. This is a quote from one of our early customers, where, as I said, their goal was really to take an application and a service. They wanted to containerize it, make it available for their users. So very quickly, we're able to get the containers and the service running on their laptop, and then of course face the challenge of how do you deploy it in production? How do you reliably get it up and running? How do you make it stable? How do you terminate services when users are not using it, right? And that's where we came into the picture. Right? So the thing that I wanted to sort of highlight here is that the space that we're in, if you start looking at the market and the domain, it is evolving very, very rapidly, right? So AWS is deploying or innovating a new service almost every day. Kubernetes is on a 2-month development cycle, right? So if you are an enterprise trying to sort of get started using all of these tools, right, in a reliable, in a resilient manner, right, this churn is sort of counterproductive to those goals. Right?
It's a lot of new stuff to learn.
Yeah, and compound that with sort of the skills gap that now exists, in your enterprise environments, right? To sort of get a handle on this innovation that is happening out there. Right? So what does the Applatix solution look like? So at its core, if you start thinking what our basic premise is, right? Our basic premise, is going to be that within 10 minutes, you will have a complete system that will allow you to develop, deploy, and run containerized applications and services, right, as part of an environment, running in your public cloud, so running in your AWS account or VPC. Okay, in order to do this, there are sort of 3 main things that we focused on. Right, so first is that we provide a set of services that are native out of the box. For example, to allow you to do your continuous integration, continuous testing, continuous deployment or delivery. These are all available as services out of the box, as workflows, container native workflows, and microservices that we have developed to assist you in doing that. Right? The second piece of this is going to be around infrastructure automation. So if you think about, if you want to get started by building such a system, you have to first figure out your core infrastructure, whether it's on AWS or Google or Azure. Now you have to layer in a Kubernetes layer, getting a Docker runtime running on top of it, and then other services that may require for you to automate the infrastructure. What we do is we abstract all of these out for you. We provide a stable running system that can scale with workflows, and but be very reliable, be very resilient, highly available. Right? Finally, once you have a system like this up and running, the next thing that you really want to start focusing on is monitoring the system, and also making sure that the auditability, the governance, all of those use cases that you need to put in place in your environment are available. So that's the final piece that we provide, is we provide that visibility, and comprehensive, auditability around everything that's going on in your environment. So with that said, I'm going to have Ed jump into some of the challenges that we are essentially resolving, and I tend to think of it as the last mile problem, right? Solving that last 30% of the cases. Ed, what do you think?
Yeah, definitely. There's a lot of cool technology out there. Kubernetes, Docker, they're both taking up really fast. Especially at kind of the grassroots or developer level. But one of the big challenges is really taking all of that cool technology or components and putting it together into a reliable, repeatable, stable system. Not just for like an individual use, but for your organization, group, or team, in order to kind of share and get productive use out of those resources. And there is quite and this typically means, of course, addressing all the problems with cloud resource management. This is running in the cloud. You'll probably want some form of infrastructure abstraction. You don't want to be logged into a particular Linux cloud. But also, when you're writing these workflows, you don't want to spend all your time, just figuring out how to provision and run infrastructure. Right? And then with new technologies like Kubernetes and Docker, while they're very easy to get running on your laptop, running them in production at scale and stably is another big challenge. Because these components are evolving so rapidly, there's a lot of interaction effects between the components. So for example, if you're not very careful in choosing the right version of Docker and the right version of Linux and the right version of your graph storage file system, and make sure that you configure things just right and you don't put too much load on the system, you're going to end up with a system meltdown, basically. Things are going to start dying, you're going to start getting kills and so forth. So knowing how to configure everything, putting it together properly, and then having some form of load regulation into the system so that you don't overload these kind of newish components which haven't been completely hardened yet, it becomes very important. Finally, because we're using containers, you can now get a lot of stats and information at a much granular level. So instead of just getting memory usage and CPU utilization for a server, you can get it for essentially a container, which corresponds to a step in a workflow or a particular application that runs on the server.
So to summarize, we are making all the open source technology much more consumable and also building IPs on top.
Yes, particularly for enterprises who don't want to build up a large team with distributed systems and cloud expertise in order to do something like this.
Okay, so now we will move to the demo, which is the fun part. We will show you how Applatix can help you set up a scalable and reliable Kubernetes cluster in minutes on AWS. We will show you a simple CI/CD workflow, and then we will also show you a complex one which our dev teams are really using every single day. Then we will deploy a containerized app having multiple containers, one for Node.js web server and another for their MongoDB database. And then finally, we will wrap it up talking about how we actually did the infrastructure abstraction optimization and how you can view all of that and provide more governance and control.
Yeah, one thing I'll add here is that these demos are all great and good, right? But the proof is, are we running it in production? And the best way to experience this, of course, is that we are using Applatix to build Applatix.
All right, so let's first create a Kubernetes cluster on AWS, and let's call it.
This actually deploys the whole product, of which Kubernetes is one of the components. Yeah.
Yes. So I'll go with the default selections. I'll create it in AWS West in the default AZ zone. You can actually create this Applatix cluster in your own VPC, in your existing VPC, or create a new VPC. over here, I'll create a new VPC, and then you can have different configuration size for your cluster. So I will pick large, and I'll show you that what are the different configuration sizes provided. Again, large means that it can go up to 20 max EC2 instances, but we will start it with only 2, and then based on the workload that you're running, it will scale up automatically. And this is one big value from our side, that you don't have to take care of any of that. Once the containers and workflows keep running, we will integrate with AWS Autoscaling Group to spin up more EC2 instances.
Right. So this is just the maximum size of the cluster. Obviously, the actual size will depend on your load at any given point in time. Yeah.
Okay. And the next selection is spot instances. You want to talk about it?
So internally today, we actually run all of our development and also actually some of our production clusters using spot instances. And depending on how you manage the spot instances, you can get pretty good availability from them. So in our typical environment, we usually actually won't lose any spot instances very often, like maybe once a month or so. And the product is also designed so that if you do start to see spot instance prices go up, the product will switch out the instances over to on-demand. So it's not like you are stuck without any instances for a long time. It's just that they will be transitioned to on-demand. So you'll never actually pay more for a spot instance, than an on-demand instance, because we'll simply switch them all to on-demand when you need to.
So next step is to do the security setup. So this is a SaaS portal from which we are deploying the Applatix cluster within your VPC. So these are the IP ranges or subnets that you want to to provide access to the cluster. And this is the IAM role that has permission to create instances within your VPC. Again, you can deploy the cluster from the SaaS portal, or if you want to do everything within your VPC, you can do it in command line from your VPC. With that, I will start installing the cluster. It takes a couple of minutes. So while that is going on, I will show, like, when the cluster is being set up, what you get to see in the logs. You get to see that first we are spinning up 2 EC2 instances. We download and install Kubernetes. We set up ELB load balancer configuration. We set up the DNS Route 53. Any other AWS services we take care of? We set up S3 bucket.
Basically everything, EVS volumes, the artifact management repository, everything you need to have a complete system. And note that we basically manage all of your networking for you as well, so including the DNS configuration, creating a cert if you don't happen to have one, all of that stuff. So once it's set up, you can actually start deploying internet-facing applications immediately if you like, or if you just wanted to be able to access it internally, then you can do that as well.
Yes, again, going back to the original premise that I set out on, right? Our goal is that in 10 minutes, you have a complete system up and running. That includes all of the ancillary services that you require, from DNS, load balancers, to get an application or a service deployed, right, running on the system. So that is sort of the focus for us, is that, if you want, to be up and running quickly, this is the way to go.
Yes. And once the cluster is deployed, it's all within your VPC. So the cluster is running within your VPC. This is the Applatix console through which you manage your workflows, your applications. So once the cluster is deployed,
I want to interject in there, right? So one of the things that we say the cluster is running in your VPC, basically you're now running within your security, your compliance, guarantees that you're giving, right?
Yes. And this is a view of our dev cluster. So you see these are the EC2 instances running, and this is based on an open source containerized app which we have deployed in Applatix. And you can see these many EC2 instances are running, and each one of these instances we are running multiple containers. Based on the namespace, you can see whether they are Applatix containers, whether they are Kubernetes containers, or some of them are apps or CIs deployed by you. So with that, we'll start with the first scenario. So I'll create a CI workflow. And but before that, the first step in configuring Applatix is integrating with your source control management system, because everything is driven by YAML DSLs, which are stored within your repo. So as you can see that you can integrate with different Git-based source control management system. We have multiple repos integrated, and then as a next step, you actually integrate it with your container registry. Again, by default, we integrate with GitHub and Docker Hub public repo.
And one of the things we really had in mind when designing this product is wanted to design something that makes it really easy to leverage source code, as well as kind of the use of Docker containers for distributing applications. And whether it's your source code or source code that already exists out on GitHub, if you want to integrate it with our platform, all you do is create a .applatix directory. You create a few YAML files there, and you can immediately start building that application, add some deployment workflows. You could use existing images that are already on GitHub. You could reference those from the YAML. And so basically in like 5-10 minutes, you can put together a complete application that runs on our platform using mostly existing stuff. So it helps you really take advantage of all of the great code and containers that are already out there.
YAML is Ed's most favorite topic, so once he starts, somebody has to.
I'm not really a GUI kind of guy, but I can see why people would find it useful.
Okay, so we will show you, this is our Applatix GitHub repo, public repo, and as he said that we have many samples over here. So we'll look at, say, CI workflow repo, which has, as he said, that there's a .applatix folder with multiple YAML files. So we will take one workflow over here.
Yeah, and that one actually has many examples in it. That's why you see many YAML files. A simple project, you might only have one or two.
One or two, yes. So this is a typical workflow. It has input parameters. So your commit ID and your repo is your input. And then there's an approval step which requires some approval input parameters. So the first step is checking out. You are checking out your source code. Then you're going to the build step.
Yeah. And when you check out the source code, it actually creates an artifact, which you can use in other steps in the workflow. So we take care of managing that storage or artifact automatically for you. You don't have to decide what to name it, or where to store it, how do you access it.
Yes. And this checkout is a container which is provided by Applatix. Next is the build step, which is another container. And I'm going to show you, we are doing a Golang build, taking a Golang image from Docker Hub, and then we are running a couple of tests in parallel. Then we have an approval step which sends an email, and then we release the binary. Again, some of these containers are provided in our sample GitHub repo, like approval, checkout, etc.
So highlighting, going back to what I was telling about is we let you have a core set of microservices right out of the box. So for example, the AX SCM microservice or the AX approval microservice, these are microservices that are available to use in your workflows. They automatically connect to any source code management system. They have the ability to check out code. They have the ability to essentially monitor for commits on a particular repo. The AX approval service is a 2-line YAML definition that you would put anywhere in your workflow. It will automatically send an email to an approver, letting them know that a particular workflow step has been run and requests sort of demands their attention.
Right. And we also have prepackaged templates for integrating with other artifact management systems, if you like. So if you use Nexus or Artifactory, it's very easy to integrate with those systems and make them a part of your workflow.
So Pratik talked about AX checkout, AX approval. Next, I'll show you the build. This is again another container which takes your source code and generates a binary. Here we are using the Golang build template. And if you see that we even manage the resources per container.
Yeah, you can just allow them to be defaulted, especially if the jobs don't run very long. But if you want to really tune the memory and CPU usage, or you have a job that you want to go is particularly CPU heavy and you want it to go fast, then you can override those defaults.
Okay, and the last thing is you can define policies to trigger your workflow, or you can run the workflows manually. But most of the time people will use policies to
So for example, when you're setting up a CI workflow, right, you want to essentially create a policy which will say, what workflow gets run, right, on a pull request, on a push request, onto which repo, which branch. Or you can just say, create a cron job and say, what, run this workflow every night or every 15 minutes. So the policies actually are designed to drive workflows.
Okay, so now let's go back to the Applatix console, and I will run this workflow manually. So this is a commit. So as you see that we have integrated with our SCM and all the commits are showing up over here, and I will create a job against the commit, and I will take example approval workflow, and I will say next. So why I have my email open is I want to show you that how it sends an email. So yes,
it can be distracting though.
Yes. So once, and I'm going to put my email address to say that, okay, this workflow should send an email to me for approval. With that.
That's also the same email you can use if you want a demo of the product in more detail.
Yes. We are always happy to help. So once I start the workflow, as you can see that it's going to spin up containers for each step. So each step will run as a container. And if you are building a Docker image, so then that container, actually the Docker will call another Docker container, right? Docker
Absolutely.
Docker.
Yes, you can arbitrarily nest the workflows and build up very complex workflows. We also have constructs to make it really easy to run parallel tests with slightly different parameters, all of those type of things.
And each step shows the logs. You can bash into the console,
Right.
But I think this step is already over. So yes. So in this step, for example, you can see the test. You can bash into the console, but the steps are running pretty fast. So yes.
Okay, so this one we caught in time. So
yes. And then in this approval step, as you can see, the tests are running in parallel. And then in the approval step, it will send me an email to approve. And then in the release step, it will create a binary which we will store.
Right. And if you want, you can actually build a Docker image as your artifact or final result. We actually support what we call Docker in Docker. So you can actually run Docker commands inside essentially another Docker container, which is a step of your workflow.
And now I'm going to approve the step, and it will move to release. So
so this is you inadvertently showed a feature I also really like, which is sometimes I'm wondering, what did I write for this YAML? And so I may want to tweak certain things. So this makes it really easy to kind of browse through and know exactly where you need to make these changes. And of course, at the top, you can see exactly what commit, and you can find out what repo it's in and so on. So it makes it very easy to modify any existing workflow.
Yes.
Modify and understand.
Yes. And at the end of the workflow, you have all your artifacts over here. We can push the artifacts into artifact management system, third party, like Nexus. You can store it in S3. JFrog.
Yeah, whatever you want. I think a lot of people use Nexus or Artifactory, but if you also have some other artifact management system, it's very easy to write a few templates to integrate with them.
So the other thing that Mukulika is showing you, which is part of, again, our DevOps service, is if you look at all the steps that this particular workflow had, now from one single page, you're able to see the steps and the corresponding logs as part of that particular step, right?
Yes.
Okay, and you can also see how much it costs to run this workflow, which
another feature, right?
is Pratik's most
One of my favorite,
favorite.
because if you start thinking about workflows that are being run as part of a team, part of a group or a department, very, very crucial to know when workflows were run, how long they ran for, and actually how much did they cost. So when you're projecting cost for a release, by project, by department, or hey, how much does it cost to run this application? Right?
Yeah.
All of that information is now available to you.
Yeah, and the cost is also a good proxy for resource consumption. So if you want to optimize your workflows to make them more efficient, this is very useful information.
Okay, so next I will go to the next scenario in the demo, which is deploying a containerized app. We have provided many sample apps as well as workflows, and you can always go to our website and sign up for our playground and play with these. Today I am going to show one of these apps, which
and
is
by the way, these apps are also defined purely by YAML. So if you just add the right YAML file, the app and you add the repo, then those apps will immediately show up here. So it's a very, I really love this because this is so convenient. Like if I create a new script or workflow, I just put it in a YAML file, and then now it shows up on the dashboard, and all of my other teammates can immediately start using it.
And this is what Ed was talking about, that in our GitHub repo, if you go to App Store, you will see all these apps and workflows, and all of them are defined as YAML, and you can take any one of them and customize it. So I'm going to show you an MLB app showing MLB data for last few years. This is an app.
Yeah, so this is a very simple database application with web server. So it will start up a web server as well as a database backend, and then it's going to like load data in the database and so forth. So you see, if you're familiar with Kubernetes, you see that this YAML spec has many kind of similarities with the Kubernetes YAML.
And that's sort of the technical definition, but really the fun part for us here was, for some of us baseball fanatics here, there's a lot of baseball data that's available out there. And one person in particular has created a CSV file with a ton of baseball stats. So what this application is doing is taking that data, is inputting, converting that and inputting it, inserting into a Mongo database. And then we have a Node.js front end, which allows us to look at that data in detail. Right?
Yeah, actually, the MLB app is basically a free app available on GitHub. The source code is there. So what we did was we took that app, we added a .applatix directory, and then we added some templating to spin up a MongoDB instance. And as Pratik said, a simple workflow to load whatever content we wanted into that database. So.
Okay, so instead of focusing on baseball, I'll focus on running this app right now. So it has one container for MongoDB and another container for Node.js. Again, this is a deployment definition saying that I'm deploying a Mongo container and with minimum one instance, and I am deploying a Node.js container with minimum one instance. In the Mongo container, you will see it has internal routes so that other services can find it.
Basically the web server.
Yes, but in the web server, you have an external route so that it's the external facing
right.
URL.
Yes.
And then we also provide a workflow which gives some steps like checking out and then first deploying Mongo, then inserting data into Mongo by executing scripts, and then deploying the web server. So I'll show you how to now run this YAML file, and you go to our catalog, and this is an example app, and you just say run. And again, it's the same workflow, which is going to first deploy Mongo and then insert data and then deploy the web server. With that, let's click run, submit, and it will submit this. It will first start the workflow, and then you will see the containers running within Applatix. So while the workflow is starting, I will show you another, because it's going to check out the container, the image from Docker Hub, and it will go through all the steps. So in the meantime, I will show you one of the running applications, and there are many running applications over here. The Kubernetes application was the application which I showed at the beginning. So this is another app, and you see that it's going to very soon show that it is running.
Oh, you actually know what each box is?
Absolutely.
Yes.
You've been looking
That's
at
one
this
of my
more
favorite
than I
features.
have.
Is being,
Yes.
There you go. See?
See?
Oh, yes. The ones that are starting will blink. Yes.
Yes. The moment they start blinking, it will. These are very active. But let's go back to the workflow to see where we are. In progress jobs, let's see how our deployment is going on. It's almost ready to
done.
deploy, and we will see it soon.
So again, what Mukulika is showing you here is really how are you deploying an application. This is an application.
And then you will be able to see the instances and the endpoints, which is the external facing URL. So let's see whether our app was deployed successfully. And remember, we are doing a demo, so
it's almost up.
yes,
It
it's
takes a little
almost.
time for the DNS update to propagate.
Yes, and Yes, now it's up.
There we go.
Yeah.
That's a completely Amazon delay, by the way.
Yes.
Route 53 delay.
Okay.
I had to say that.
Yes, you had to say that, but it's true. With that, let's go to the next part of the demo, where we will see how to actually view what your development team is doing. And this is where Ed loves to see it. He's monitoring all the time. Yes. And you want to talk about this?
Actually, let's go back and watch about the last 15 days of activity, so you can see how the system is actually running and deploying.
Actually, I think this is a demo cluster, which
there
I think.
There you go. That's a very beautiful picture.
Yes.
Yeah. So basically, the white line is the resources that you're actually provisioned and that you're using, or that you've provisioned, and the blue line is the what percentage utilization, or how much of that resource you're actually using. In this type of system, unless you have a very steady load, 24/7, it's very hard to get beyond about say 70% utilization. So 50, 60, 70 is a very high level of utilization for this type of system. If you have a very static workload, very steady job flow, then you can get 80 or 90% utilization. And then on the bottom, what we show is that if you select a time point along that line, it shows you which applications and also which users are consuming most of the resources. So on the left, you see, there's in application-wise, there's a Mongo deploy and the MLVDB and so on. Now this is a demo system, so we're usually not placing a heavy load on the system, which is why a lot of the resources are also used by our system processes. And then on the right side, you can kind of see spending by user. Actually, looking at this, I can kind of tell who's been giving more demos recently. So
yeah, we need to make you give more demos.
You're a front runner here. You've edged out Scott by a little bit.
Okay.
The other thing that we wanted to highlight is that when you start looking at this graph, as you're looking at the white line there, what you're seeing is really your Amazon spend or your AWS spend. The shaded area is showing your utilization. But as you start seeing, you see how when the workload actually drops, the system automatically scales down, the Applatix cluster. As the workload starts increasing, you start seeing a scaling up the workload cluster, right? So again, you don't have to do anything, as regards to how to scale up the cluster. Automatically, when you're starting to deploy workflows and starting to use the system is going to start taking care of it. How do we do that? We start monitoring various heuristics like your memory utilization, CPU utilization. All of those things are monitored and then figure into how we scale the cluster up or down.
Yes, infrastructure automation and optimization is very strong part of this system.
Yeah, so basically you're just continuously getting whatever resources you need to burst your workloads, run them very quick, ship your software faster, but also is powering down everything that's not needed when you're not using it so that you can save money at night or weekends or other periods of downtime.
Okay, so just to recap, we showed you CI/CD workflows, how to deploy a containerized app, and also how we are managing infrastructure abstraction and optimization, how we are using spot instances, and anything else you want to add?
No, I think you covered pretty much everything.
Okay.